So yeah, let's talk about JSON. My rabbit hole that's lasted, I think, for 8 years now. I'm actually gonna talk about how this all started. So yeah, it's very much one of those rabbit hole projects. So it started. Erlang standard library has this module called leaks, which is a Elixir generator. It's really nice and very useful. At the time, I was not a big fan of it because, like, I wanted to kind of improve on top of it because I wanted it to work on binaries because it works on char lists. And so I dove deep into writing something that can parse binaries, right? Generating Elixir for binaries. And I wrote a small library. I think it was sometime in 2016, so a long time ago. With kind of Elixir generator, like with a nice Elixir micro API. And I learned a lot going down this rabbit hole, learning kind of about binary parsing and then various optimizations and different things you can do differently. And yeah, as at the time I was working mostly with Elixir. I haven't done much with Erlang. And this was also kind of soon enough after I did that work. There were quite a few JSON libraries for Elixir. The most popular was Poison. And at the time, it released a new version that broke some of the APIs that Phoenix was using. So it effectively required some bigger changes with Phoenix. There was kind of a bit of small drama. And I decided to apply the knowledge I gained building this Elixir generator into writing JSON. So that's kind of how JSON was born. And it was released in 2018. And kind of to be fair, since it was released, I didn't have to do much work on it. So there's like some maintenance release around once a year. But other than that, it all works together. And if you're not familiar with it, it's generally very small API surface. Kind of you have two main functions, one encode, one decode, and you pass it kind of a map as you'd expect, get a string back, or the other way, pass it a string, get a map back. And it also has a protocol for kind of enhancing, mostly for third-party libraries, if you want to define how it should be, your data type should be transformed into JSON. And yeah, I think right now it is the most popular package on Hex with something like 160 million downloads. So hopefully with the work I did that year, we can deprecate it and don't need to use it anymore. So yeah, this is a story about Elixir. What about Erlang? And in particular, what about state of Erlang, state of JSON in Erlang? And it is a bit of a mess. Right? There's a couple popular libraries, but the main problem is that a lot of them were written at a time when Erlang didn't have maps yet. So there was no obvious representation for objects in Erlang. And so each library came up with their own idea of what to do. There was even in 2008, there was an EEP to add JSON to Erlang standard library to the Erlang module itself, similar how you have binary to term and term to binary, to have term to JSON and JSON to term. This kind of never was implemented. I'm not sure why. My presumption would be kind of those problems with representation. Exactly. And we can see those problems with representations looking at the JSON-E, one of the more popular libraries in Erlang for JSON. So by default, you get a map, but you can provide an option where you get a one single element tuple with a prop list inside, and or you can just get a prop list. Some other libraries have what I call prop tuples, where you get kind of a prop list, but instead of a list wrapping, it's a tuple wrapping pairs of elements. As I said, it's a bit of a mess and kind of nothing is consistent. On top of that, there are more problems with Erlang in that with Elixir structs, it's fairly easy to encode them to JSON because they carry the keys with the values. But in Erlang, you have records, and then you get the record, and you need to have some sort of heuristic that figures out that, like, oh, a tuple with this tag and this many fields, this kind of looks like that record, and then so we'll use those keys. But it's, as I said, it's mostly heuristic, and it's a bit of a messy and not elegant solution. On top of that, you have some data types in Erlang standard library, like, for example, the calendar module, that do not tag their tuples. So you get a date, which is basically a tuple of 3 integers, and kind of figuring out, is this tuple of 3 integers actually a date, or is it just some random tuple of 3 integers? Right? And differentiating between those is a bit problematic. So yeah, early this year, I proposed EEP68, proposing adding a library for JSON to standard library of Erlang. But you may ask, why add it to standard library? With Elixir, I released it as a separate package. Why not kind of have yet another library for Erlang doing JSON instead? And I think there are a couple unique advantages of something like JSON being added to standard library rather than as a third-party package. In particular, and I think this one is most convincing to me personally, is that there's quite a lot of fundamental tooling where managing external dependencies is difficult, but JSON can be useful. And one of them is build tools. Several of what I would say like large-scale build tools like Bazel and Bach rely on JSON quite a lot. So not having it is a bit of a hindrance. Kind of, if your compiler build tool requires an external dependency, how do you compile that dependency? You get a bit into a chicken and egg problem, and having that in standard library is something that's just available, makes it much easier. And so I gave myself a couple goals with the JSON library. One of them is that it should be easy to adopt in code bases using one of the existing libraries. So like the migration should be fairly simple and possible, which implies that also it should be flexible enough to support all those different formats and different ways that people use JSON in the Erlang ecosystem. At the same time, if you just want something simple, it should be simple, right? You don't need to go and picking through all those different formats and dealing with the legacy if you don't have to. And finally, I wanted, even if kind of I need to add extra flexibility, which almost always inherently implies loss of performance, my goal for myself was to at least not regress performance compared to the Elixir JSON library. And kind of a personal goal for me was, okay, can I kind of, if I write the Erlang one, can I make the Elixir one just a thin wrapper or something that I don't need to maintain it anymore? Kind of, it lowers the burden there. Yeah, so the API is fairly simple and quite small, but going deep. And this is the type of libraries I generally really like small, focused APIs, but doing the one thing it's designed to do well. So it provides encoding, decoding, and there are two additional requirements that came here from my conversations with the OTP team, which was one was decoding messages that don't fully fit into memory. So if you get kind of your data streaming, and then we'll talk a bit about that, then like it should be possible to kind of decode stuff without concatenating into one massive string before parsing. And again, JSON is a thing that's defined in parallel by two standards, an RFC and an ECMA. And so it should be compatible with those. It should pass like some open source test suites. So it should be standards compliant. And I came up with, for the simple API, with some sort of very, I think, natural mapping of data types, right? That numbers are integers or floats, and booleans are true false. Null becomes the atom null. and so on. But one of the important things that is to note here is that you cannot do a round trip without losing information, because JSON has a much smaller variety of data types compared to Erlang. One, there are some Erlang types we cannot encode into JSON, and you'll get an error by default. For example, PIDs and references and other things like that. But also even tuples, right? Since there's not really a natural representation for a tuple in JSON. But then for some things like using atoms as strings or as keys in maps, it's fairly common in Erlang. If we want to support it, so you can encode stuff like that without having to coerce it first, because they're just not very practical. But then when you decode it back, you always get binary keys, right? So some information is lost in that process. And the big idea behind the API is that for both encoding and decoding, you generally get two APIs. One, which is the very simple, small, convenient API that does kind of the default thing well, but then you also get a fully customizable API where you can kind of do more abstract things if you have to, and kind of provides full flexibility that you need. So as you can see, the small API, or like the default API, is very similar to what we got in the Elixir land. You just pass it a string, and you get a map back. As you might know, here I'm using the new feature that was also introduced in 27, which is the sigils. So you no longer need to write the square bracket, the angle brackets, and like /UTF-8. You just get a nice UTF-8 binary with simple notation, no quote escaping. I'm a big fan. So this is the API, the advanced API, as I call it. And here I omitted the definitions of all of those options. But the big idea here, unlike the existing libraries, is that rather than being a set of options based on values that you pass around, and then internally in the library there's some switching going on, this API relies on callbacks. Right? So you effectively can customize various steps of the lifetime of the JSON document while it's being decoded, what happens at different steps, right? So what happens when you start an array? What happens when we push an element to an array? What happens when you finish decoding an array? And of course, all of those have default values, the ones that are well-defined, that effectively implement the simple API that we got in the first case, but you can fully customize it to achieve all this flexibility of different libraries that are out there. And so here we have some examples. In the first case, we effectively implement a feature of decoding keys and existing atoms. So to do that, we override the object push callback and kind of do the binary to existing atom call there that we can do. And as you can see, it is more verbose than what you would get with one of the other libraries, right? When you would just pass a single option. On the other hand, it does give a much bigger flexibility. And in my mind, this was a good trade-off for something that goes into a standard library. You can always have a thin wrapper around it, providing a more convenient API if you need it. But the big advantage is that you can do things like prepend X to every decoded key, right? Something that's not possible in the existing libraries, and who knows, maybe you might need that. And the last example here, we have kind of replicating the format of this like single element tuple wrapping a prop list, where here we override the object finish callback, right, where we wrap the accumulated value into a single tuple and return that. But you also might have noticed that in all those return values from the advanced API, there's a third element, which we return what was remaining in the binary when we finished decoding. And this is what allows decoding strings or kind of byte streams that have multiple JSON values in them. So you might imagine reading a file into memory that has a new line delineated JSON objects, and then you just call JSON decode multiple times until you get the empty string at the end. And the additional API that's a bit more complex to implement, but I think also quite interesting, is what I talked about in the beginning. It's kind of the ability to decode incomplete messages. So for that, we have a separate API where you can call JSON decode start and pass it some prefix of your data. For example, here we have the opening array and then just 1 and the comma. And then we call, and this will return to us some continuation, and we can call decode continue with the remaining data passing all of it. And of course, those two features that I presented here can be combined. So if you're dealing with some weird network protocol that sends you data over TCP without proper framing, and there's a lot of weird network protocols out there, you can just pass those the data directly into the decode function, and then they'll figure out by themselves where one message ends, another begins, without need to kind of do some manual bookkeeping on the side. As there's also, that I won't go deeper into, those kind of additional accumulators that are passed around and things like that. Those allow for even more flexibility into some sort of partial decoding and threading some value across the different decode steps, and kind of for even more advanced use cases. So encoding API also has two versions. Again, we have the very simple encoding API where you just call JSON encode and it returns IO data, and that's it. You can convert it back to a binary for something that's easily legible on a slide. And then again, we get the more advanced API that allows you for full customization. And in this case, the API is just this one function encode that's actually relevant. All the other ones are helper functions that the module also defines. And again, the big idea here is that instead of using options, we're using callbacks again. And so effectively, you provide to encode a callback that will be called at every step recursively while you're encoding your data type with whatever we got at the particular step. And those are the places where you can customize your encoder to handle things like records, to handle things like date tuples if you want to handle things that are, let's say, less conventional or kind of more custom from that perspective. And to make that easier, the module provides a set of kind of predefined functions that you can use from your own callback to make that easier and to make implementing those customizations simpler. So we have an example here using another recent feature in Elixir that allows us to define a function in the shell. That's also quite nice. But yeah, here we provide an encoder that uses some heuristic to figure out if a list is a prop list and we should encode it as an object, or it's just a plain list and it should be encoded as a JSON array, right? And then we can call JSON encode, passing a prop list of A and B, and then we get an object back as we'd expect. So again, this API is a bit more verbose compared to what you'd get in kind of pure options-based API, but it provides much more flexibility and is more powerful compared to what's available there. So, and it's fast, right? So let's now go to the section when we talk about why is it fast. But yeah, is it fast? That's kind of, I jumped the gun a little bit there. And yes, it is fast, except for some very special edge cases with a lot of weird Unicode situations. It is the fastest library out there. The only one that beats it on Unicode cases is the Jiffy, which is implemented as a NIF. But in regular kind of, I would say, most normal JSON messages that you might expect, it is faster than that library. On decoding, is about 30% faster than the existing Elixir JSON library on encoding is about 15% faster, but it can be up to twice as fast. And then comparing to JSON-E, which I think is the most popular Erlang package, there's quite a few performance wins there as well, due to like different approach to decoding. And here, clarifying the comparison to Giphy, which is implemented as a NIF. It is implemented in C, and I'm not claiming here that Erlang is as fast as C. I'm just claiming that this particular library that has a JSON parser implemented in C, but in a relatively naive way, we can beat that with a version in Erlang. And there exist libraries in C, C++, Rust that are kind of order of magnitude probably faster, if not more, if you need that speed. And that's kind of currently probably unachievable with a pure Erlang implementation. But one important point with comparing with the NIFs is that NIFs have inherently more overhead when pattern matching or constructing data types, because they need to go through the overhead of the dynamic calls to the dynamic library of NIFs. And Erlang, especially with JIT, can do those things like allocating data types and pattern matching, extracting values actually quicker. So if you have pure kind of data structure manipulations, they will probably be quicker in Erlang compared to a NIF that you might write. So let's dive a bit deeper into some of the things I did in the library. And one of them is a custom UTF-8 decoder. So in particular, in Erlang standard library, you have the /UTF-8 thing in a binary that allows you to extract a code point. But the interesting thing is that when we decode data here, we are not actually interested in what the value of the code point is. We just want to validate that it is correct UTF-8. And we can actually do that quicker with a custom state machine. I did not come with it myself. There's this gentleman, Björn well, I won't attempt to pronounce it, maybe. But yeah, there's a really great website explaining how this works. And I implemented it in Erlang. Implementing this in Erlang, this specific approach, wasn't even my idea, because I first noticed in Cowboy that does it when dealing with HTTP traffic. I think my implementation that I did now is actually faster a bit compared to the Cowboy implementation, mostly because this one was written after JIT was a thing, and I was able to tweak some things and then create code patterns that the JIT optimizes slightly nicer. But as you can see, it's effectively a state machine where for every byte we read some kind of offset value and we add it to the previous state in our state machine, and we dispatch on that. If we reach the accept state, we know we've read a complete code point and it's valid. If we read the reject state, we know something went wrong and this is not a valid UTF-8 value. Another kind of trick that I used here that's not used in JSON was decoding multiple or kind of skipping multiple bytes at the same time. Because by far the most expensive things in dealing with JSON is escaping and unescaping strings. And most of the time what you're actually doing is just skipping over bytes that don't need to be escaped. Since most of the stuff is ASCII, and even Unicode, you actually don't have to escape as long as it's a valid Unicode. So you just want to kind of skip those things as fast as possible. And then if you read bytes kind of from the binary byte by byte, there's some inherent overhead in like the function call, and the reading, extracting something from a binary, kind of adding some sort of tracking that might be happening. So what I'm doing instead is I'm extracting 8 bytes at a time and checking that all the 8 bytes are a simple ASCII that don't need escaping, and then I'm skipping all those 8 bytes at a time. If not, then there's a fallback when I go byte by byte. So it is possible that a single byte will be processed twice. Once in the general skipping when we notice something's wrong, and then again in the byte by byte loop. But the fact that skipping multiple bytes at a time is so much faster well pays off for the fact that sometimes you might do something twice. And for this specifically, I also have some more ideas how to optimize it even more. So it might get even faster at some point. We'll see. Yeah, and another thing that's quite useful in performance-sensitive code is inlining. If you've ever had a compilers course, you've probably heard that inlining is by far the most advantageous or important optimization the compiler can do. And the Erlang compiler doesn't do it by default. Mostly because there are challenges in changing semantics of the code. Because the most important one is you lose tracing. You lose tracing, stack traces end up slightly different, and so kind of this trade-off between slightly better performance or like losing tracing or kind of slightly worse errors and then things like that was kind of conservatively by default the Erlang compiler opts for staying kind of not doing the inlining, but you can opt in. And in this case, it's quite useful. Though you also have to be careful because inlining is not always an optimization. Right? You can make things worse because it blows up the size of the code, and this might end up slower. Another, I think, interesting thing is so kind of naively, if you want to check if something is between 1 and 9, you'd use just 2 comparisons. But in particular, if you have a sequence of checks like that, right? So for example, you check first if it's 1 to 9, then if it's A to Z, and something like that, it might actually be more efficient to explode those checks and compare with each value separately, because then the compiler emits a slightly different code, commonly referred to as a jump table, that ends up being more efficient in practice. And a lot of this stuff is in the OTP documentation. The Erlang efficiency guide is a great resource that's kept up to date by the OTP team. And I would refer you to reviewing it. It has a lot of accumulated knowledge over the years that's kind of relevant for each version. And I'm stressing the version fact because the JIT initially and with each release, the improvements to JIT mostly don't change what code is fast, but then make some code that was preventing some optimizations or kind of stopping some efficiency things, removing those barriers from the optimizations, so you can be more flexible with what kind of code you can express. And speaking in particular by binaries, by far the biggest optimization the compiler does is that it can actually look in some places like this function here where we have after 0, in particular the second clause where it says optimized. And you can see that like this T itself and this overall binary, nobody's actually looking at the binary itself, right? We're just passing T to another function that does pattern matching on it. And the compiler and the runtime system conspire in this case to, instead of actually using immutable values, to using a mutable state underneath, that kind of, if you cannot observe something is mutable, is it really mutable, right? But it gives great performance wins because you're effectively doing a mutable loop like you would write in any imperative language for kind of reading stuff from a byte stream, byte by byte. But it does impose quite a severe restriction on the code you can write, because this tail, you can never actually return it. The only thing you can do it not to break the optimization, and I think there's some work going on to make this more flexible. But as it stands right now, the only thing you can do with it is effectively pass it to another function that will pattern match on it. And so this implies a very specific style of code where you never return from a functions. You just pass as tail calls forever and ever and ever, right? And this implies that for some things where, for example, if you have a nested array in your JSON, if you implemented it naively, you say, OK, like I have this array. Those are the values I decoded so far. I noticed I have a new array. I'm going to make a call, but kind of keeping call to decode the inside of that. And then I return from that function, and I continue decoding the parent function. But we cannot do that because we cannot return. So we have to explicitly keep the stack or the state of our computation in arguments to our recursive calls. And this is effectively what we do here, right? If we notice that we're starting a new array, we push to the stack some sort of marker value saying, oh, we're now parsing an array, and this is some like old state that we had, and then we go parsing a value, which might end up being another array, so we might recursively end up in the same function. And then once we're done parsing a whole value, all the code paths end up in this a bit magic continue function that looks at the stack and then decides where to pick up the computation, where to resume the computation we've paused before. Right? So if the stack is empty, it means we're done parsing. If we have this marker array thing, we've just parsed another value inside of the array. If we see this object marker, then we've just parsed the key of the next pair in the object, and now we need to parse a value. And otherwise, we assume this is the key we think we've parsed before, and we just parse the value, so we kind of push the whole pair to the object that we've decoded. And there's kind of several smaller things that are also important for this, and I think by far I think the most important one is that binaries are just much faster than strings, and even if theoretically strings have better like big O performance that you might think, computers are really fast at copying consecutive bytes and really slow at pointers. And this implies that the threshold at which the theoretical benefits of having, I don't know, like some sharing of tails and things like that that strings can do, Erlang strings, that binaries cannot, actually the threshold is much further away than you might think, and the extra copying that binaries might do is actually not that big of a deal. And then there are some other things that, like, in general, prefer syntax to BIFs to remote calls, right? So one example would be, I don't know, pattern matching with the map syntax rather than using the maps get call. Though I think in recent release, the compiler actually optimizes both the same way. But in general, since Erlang, the compiler compiles a module at a time, it cannot see across modules, so it cannot do any optimizations across modules, and the syntax can be optimized better. Similarly, if you can express something with a syntax as opposed to a BIF or like a guard or something like that, generally syntax also will be optimized slightly better by the compiler. But I want everybody to pay attention to the last point I have here, which is measure. Right? The one thing about performance work is that you have to always measure. You have to first measure that you actually have a problem, because that's an easy assumption to make. Then you have to measure where your problem actually is, rather than making assumptions where you might think it is. And final thing is, when you've applied the solution, you need to measure you've actually fixed the problem. And so measuring becomes the fundamental part of performance work, and you should never do any kind of things blindly whatever anybody might say, without measuring. And when we come to measuring, there's this great library for Elixir, and actually can be used from Erlang as well, called Benchy. And I recommend everybody to look at it for their benchmarking needs. That's what I used initially for JSON, and now for the OTP contribution as well. And it's works really great. Also, another tool that's really useful that we got since JIT is Linux Perf, that the JIT integrates nicely with Perf, and it's an extremely powerful tool that comes with kind of standard on most Linux distributions. Kind of integrates with kernel. It's a sampling profiler that can gives you call stacks and kind of annotate even at like CPU instruction level, assembly level, where time is spent. Can give you flame graphs. You can get a lot of really in-depth performance information about your code, and it's. I think besides JIT making our code faster, this is actually a great contribution thanks to us having JIT, that we can use tooling like that. But the last tool I've been using a lot, both kind of throughout this journey with all the libraries, is just staring at assembly and figuring out like, why is it that way? Wouldn't it be better if it was differently, right? And initially I just had access to bytecode before we had JIT. Now with JIT, you can also get the actual assembly, whether it is ARM assembly or x86, and look at that. It's a bit easier to get it from Erlang. Getting it from Elixir is a bit tricky, especially the bytecode. So the easiest way I found in Elixir is to actually compile the code and then extract from the beam file the bytecode itself. And then I wrote this small library, though I'm not sure it actually still works. It's been a while. But yeah, contributions welcome. So throughout this talk, I've been talking about this module for Erlang. So this module has been released in OTP 27, and you can use it from Erlang, and you can use it from Elixir, just calling the Erlang module. But in the coming days, I will make a proposal to the Elixir core team to include a thin wrapper around that in Elixir standard library, so everybody can use that. And I can hopefully deprecate my JSON library kind of long term, eventually. So don't worry, right? It's not going away, but it will be put effectively in maintenance mode. But yeah, that's it. That's what I had for you today. Thank you very much.
Yeah, thank you very much. I don't think I've ever spent time looking at what kind of bytecode my code generates. So, as I said, you're really taking a deep dive. We have time for 1 or 2 questions, and then if you have additional questions, please use the Huwa app to post them as well.
Hey, Michał. One of your suggestions for performance was to avoid unions as arguments. Can you expand on that?
Yes. So this mostly comes from like the way that the compiler optimizes types. For example, if it knows the argument is an integer, it can do kind of emit much more efficient code than if it doesn't know that and it sees like, oh, it's an integer, but sometimes it's a float. And one of the common patterns that kind of break that is in recursive functions, when you have a first clause that does some messaging of the arguments to kind of make them look nice, right? Like coercing everything to integers from floats or something like that. And then you have, in the same function, you have the other clauses implementing actual loop. And in this case, the compiler cannot infer that it will always be called with those nicely coerced arguments. So it's better to implement those as 2 separate functions, right? Where you have first step doing those whatever coercion or massaging of arguments you need to do around, and then the second function doing the actual loop, where the compiler will have all the information about the arguments.
Hi, thanks for the talk. So there are a bunch of like own unholy variants of JSON, for example, with comments or trailing commas and stuff. Has there been any thought put into this library to like be able to handle them? Are there any callbacks they could use today, or is it something that's not supported?
So this just supports plain the simplest JSON. There is like the standard one. There is no support for the variants with comments or commas and then things like that. And I do not plan on adding it at this point. Though it lives in OTP, so you know, EPs are always a possibility. I will probably weigh in heavily if there's a discussion, but you know, I'm not the final vote anymore on that. But I prefer to keep it kind of small and then focused on this and kind of giving up all this flexibility, since again it probably some of that flexibility, especially if you want to kind of enable it, might impact on performance. So I didn't want to do that.